Hello everyone, welcome back to my channel Chemical Engineering Education. Today we are tackling one of the most important industrial processes, drying operation. Here we will solve complete wheat grain drying problem. This type of drying problem you may encounter in food processing, pharmaceutical and chemical manufacturing. So by end of this video, you will have mastered drying mass balance calculation and understand exactly how moisture removed work in industrial dryer. You know, drying is everywhere in industry, from breakfast cereals to life-saving medicine. So today's problem involves a continuous tray dryer which is commonly used in food processing plant worldwide. Here is our industrial scenarios. We are processing wheat grains in a continuous tray dryer. So our feed enters 1500 kilograms per hour with 25% moisture content on a wet basis. So we need to reduce this moisture to 8%. So hot air at 80 degrees centigrade enters the dryer at a 3000 kilogram per hour of dry air, and our objective is to determine dried product, what will be the total water removed and condition of the air leaving from the dryer. Before we start the calculation, let's clarify moisture content terminology. So that is very important for doing this calculation. So here you can see that we are sending feed with 25% moisture in wet basis. So what does it mean that wet basis? So wet basis means moisture percentage is calculated based on total weight containing water. So 25% moisture means 25 gram of water per 100 gram of total material. So this is the difference from dry basis, where in dry basis where moisture is calculated relative to only the dry solid. So you know, wet basis is more common in industry because it is easier to measure and understand. And here, so from this that wet basis, the critical principle in all drying calculation, dry solid remain absolutely constant throughout the process. So water is only component being removed, and this principle will guide every calculation. Step 1, let's break down our wet feed composition in details. So we have 1500 kilogram per hour wet wheat enters the dryer at 25% moisture on wet basis. So water in feeds equal to 1500 times 0.25, so that will 375 kg per hour water. So this is the water we need to remove to reach our target moisture content. So dry solid in feed, so that is equals 1500 kg per hour times 0.75, giving us 1125 kilogram per hour dry wheat solids. So these 1125 kilogram of dry solid are our constant throughout the entire process. Whether the grain is wet or dry, this number never change. It is like the backbone of our mass balance calculation. Step 2. Now let's calculate the dried product flow rates with detailed reasoning. Our target is 8% moisture on the wet basis in the final product. Let's call the total dried product flow rate, that is P. So here is the mathematical setup. If the P is our total dried product, then the water content in the products equal to 8% of P, or 0.08 times P equal to water content. Then the dry solid in the products equals the total product minus the water contents, means P minus 0.08 P. So that is equal to 0.92 P. So that is nothing but 1125 kg per hour. Since dry solid mass remain constant at 1125 kg per hour. So from here we can write that 0.9 to P is equal to 1125. From here we can easily calculate P. So P is nothing but 1125 divided by 0.92, that is 1223.9 kg per hour. So that P is the total dried product including water. So in that total product, so now if I calculate the water, so water in that product, so that will be 1223.9 into 0.08, so that is 97.9 kg per hour. Step 3, calculate the water removed using mass balance principle. So water balance is nothing but water in is equal to water out plus water removed. Now here water in is 375, means that is in the feet, and water out, so water in the product, so that is 97.9 plus water removed. So now we have all this data. So from here we can easily calculate water removed. So from here we can get that water removed W is nothing but 277.1 kg per hour. So this water is actually carried away by the air steam. This means we removing 277.1 out of 375 kg per hour of water. Step 4, calculate the air outlet condition. So the dry air flow remains constant, that is at 3000 kg per hour. However, this air picks up 277.1 kg per hour water. So total humid air outlet, so that is 3000 plus 277.1, so that is 3277.1 kg per hour. Now from here, so humidity of the outlet air, so that will be 277.1 divided by 3000, so that is 0.092 kg water per kg dry air. Now step 5, let's verify our overall mass balance to make sure everything checks out. So input wet feed plus dry air, so that is wet feed is 1500 plus 3000, so that is 4500 kg 00 kg per hour, and output dry product plus humid air. Dry product, that is 1223.9 plus humid air is 3277.1, so that is 4501 kg per hour. So difference is here, that 1 kg per hour, so means rounding error. So now our mass balance actually satisfied. Now step 6, calculate the drying efficiency and performance matrix. So moisture removal here 277.1, so that is that water actually removed, and originally we have 375. So moisture removal will be 277.1 divided by 375 into 100, so that is 73.9%. And final moisture content we already know, that is 8% weight basis. So now from here we can easily calculate air utilization. So we remove 277 kg of water per kg of per 3000 kg of dry air, and we already calculated that humidity of the outlet air. So specific moisture removal is 0.092 kg water by kg dry air. Now here is the result summary. So dried product, so P, so that is 1223.9 kg per hour with 8% moisture. Water removed, W is 277.1 kg per hour, and if we do the calculation, that is nearly 74%, 73.9% of the water feed of water. Humid air outlet, so that is 3277.1 kg per hour, means that 0.092 kg of water by kg dry air. Productly we can easily calculate, so that is nothing but 81.6% of the wet feed becomes dried product, and drying difference, that reduced moisture from 25% to 8%. So now, so this type of calculation you can get in food processing industry, pharmaceutical tablet drying, and chemical powder production. So from this problem, the key takeaway is Always remember that dry solid remain constant in drying operation. So this principle simplifies all your calculation. So if this video help to understand that drying mass balance, hit that like button and subscribe for more chemical engineering solution. Or you can drop a comment with your own drying problem. I might solve them in the future videos. Thank you. Thanks for watching.